right, class. I got another extended holiday. Um, my boys were sent home from school with COVID symptoms, and my wife and I are not sure. We're going to all get tested, um, but it'll take 5 days to get the results, so I won't see you guys until next week anyway. So I decided to make a video of the direct instruction that we missed yesterday because of the internet being down, and today because I'm absent. So I just have this dinosaur track here with me that's part of this presentation, and I just want to show it to you up front and point point out some features that you might notice or may not notice. Uh, Obviously, this is a three-toed dinosaur, so this is one that was like a predecessor to the T-Rex. This is an ancestor of the or a predecessor of the T-Rex, and you can see a toenail right here, and you can also see another one right over here. It's harder to make out the one on this side over here. But this is a pretty big footprint. I mean, it's probably about like a size 10 or 12 from heel to toe. And it was walking around in a dried up lake bed, or a wet, marshy, muddy lake shore in Virginia, and a place called Culpeper, Virginia. It was an old lake, which I'm going to tell you about a little bit in the presentation. But I just want to show you this because you could go make one of these yourself. The quarry where this is found is still open to the public, but it's now run by the Virginia Natural History Museum or something like that out of Richmond, and they lead tours on the weekends. I got in there before the rush. I got in there with some USGS scientists, and me and my students got to help out with some of the research by helping them map out the uh, the trackways. It was a really cool thing. It was just discovered at that time, and so there was a lot of excitement about it. But at least you can still see them. And here's some proof that in Virginia we had dinosaurs. All right, so back up to the presentation. Right, there we go. All right, so sedimentary rocks. These are my favorite, and it's not because I think they look cool. It's because the story they tell. Okay, so the rock cycle. We started out up here at the top with magma, and then we went through crystallization to make, big and small crystals, and that formed igneous rock, and then we have weathering and erosion and deposition of sediment, and then that gets compacted and cemented together to give us sedimentary rock, and then you're going to find if we heat it up and expose it to pressure, it will get turned into a metamorphic rock, and then if it gets cooked even further, it's going to melt and become magma again, and that starts the rock cycle all over again. But notice that there's lots of shortcuts that can happen. You can have an igneous rock that melts and goes back to magma, or you can have a sedimentary rock that gets weathered and eroded, and before it gets a chance to become a metamorphic rock, it gets eroded and becomes sediment again, and it starts all over. Sedimentary rock becoming sediment to become another sedimentary rock. The possibilities are endless. Just keep in mind that this is not a purely circular cycle. It has a lot of shortcuts. And this is just another way to visualize it. I'm not going to talk about that. All right, sedimentary rocks also have these strange structures in them that are all formed during the deposition of the sediment. This happens to be fossilized sand dunes. This is out in the Navajo. It's a Navajo sandstone. It's actually on public land and on a Native American reservation. And the problem with this site is now that people have GPS in their phone and everything, that when they take pictures of this place and they tag them in their emails or their text messages, and people can see exactly where this picture was taken, it makes a lot of people want to go there. And unfortunately, going into this landscape is like going into a scary fun house. If you notice, you can go in all these different directions and it's endless. And if you did that, this wavy structure is going to become very confusing. You're not going to know where you are. And unfortunately, it's a dry climate and people have gotten in here and gotten lost. and they didn't find them. Uh, so now when you go in there, you have to make a reservation. 10 people are allowed every day who just show up in their cars, or first come, first serve, and the other 10 that get to go in have reserved their space years or months in advance so that they can time it just right for the day they're going to visit. Um, but this is a sandstone that's got some iron in it and then some clean quartz sandstone. And the clean quartz is obviously the white part, and the iron stain, the iron has rusted. And it gives us this distinctive wavy characteristic, and that's why they call it wave rock. Okay, sedimentary structure like from a sand dune. So why are sedimentary rocks important? Well, if you think about it, if it's sand dunes, what does that tell you about the past environment in this place a long time ago? It tells you that this used to be a desert, and it had moving sand dunes like you see in Africa or in Sahara Desert and other deserts with big sand dunes. That tells us some history about the place in the past, that it was a drier place. So because of sedimentary rock textures, we can tell a couple of things. We can tell about past climates and environments, and we can tell about the history of life in the past on Earth. They also contain oil and gas deposits. So if you think about it, there are three really important things about sedimentary rocks. They tell us the history of the past environments, they tell us the history of life on Earth, and they also contain all of our fossil fuels and natural gas deposits. There's a great picture of the biggest or the longest book of rock history that you can read. This is the Grand Canyon, and it is the longest continuous, well, it's actually not even continuous. It's got a lot of pages torn out. We'll talk about that later on. But this stack of rock is the most history of the Earth you can take in with one glance on Earth. And of course, it makes these great features. And this is why people go to these national parks. This is Arches National Park. And people love to go here to see these structures that have formed from wind and rain, and a lot of scouring from wind erosion. And there was some salt mixed in with these, and it dissolved. And where it did dissolve, it weakened the rock. And that's what helped open up these passages. This is a famous place called Escalante Canyon. It's also a wavy sandstone sand dune deposit. But what's significant about this is that you got to be really careful doing this type of exploration, because think about it. If you have it might be sunny right over your head, like on the left side here, but if 30 miles upstream there's a flash flood happening because of a thunderstorm, and that water comes down through this channel, where are you going? Are you going to outrun it? And the water can't spread out, so where does it go? It goes up. And if you go into one of these channels, you'll often look up and see trees that are stuck, old trees that are stuck above your head 30 feet up. That's how high the water gets. So you want to get out of there. You don't want to go hiking in here in the summertime in the middle of the afternoon when the thunderstorms might happen. There have been some sad stories, including a Boy Scout troop that was in there when the floods came. All right, and this is another example of weathering and erosion. The sand is blowing around here is scouring the bases of this sedimentary rocks until they basically topple over. Okay, this is shale on the bottom and it's sandstone above, and it looks like another more durable sandstone on top and a sandstone below. These fossil sand dunes, these ancient sand dunes, you can see how they form. It looks kind of like feathers. The sand is being blown up the like gentle side, and then it goes down the slip face, and that creates these lines that you see. Okay, and that's a person sitting there. So you can see how big these are. This is like one migrating sand dune, and then another migrating sand dune that eventually migrates over it. These are multiple sand dunes traversing this environment long time ago, back in the days of the dinosaurs. And I just love the scenery. I mean, this was all continuous. Take a look at this. Think about this. This was all continuous. This is the top of the land, matches up with this top and this top, but what's happened to all this stuff in between? It's gone. That's a lot of erosion. Think about, try to imagine in your mind putting all the land back and how much erosion had to take place to leave only these little remnants sticking up. Okay, and here's a great example of sandstone that's being eroded into sand again, and then this sand itself is going to be possibly compressed and turned into stone. So this is and also it has a sedimentary structure in it called ripples, and we can tell that those are wind-blown ripples by their structure. There are actually people that are experts at that, but these are wind-blown ripples, and if this rock gets buried and compressed, those ripples will be in the rock, and when you dig it up and find it millions of years later, it will have those ripples preserved in it. Okay, and beautiful nighttime sky. You don't get that like that. You don't get skies like that here. There are no cities out here, so you get no light pollution. Just had to include that. All right, and I love this picture. At least that's these sets of pictures, because this is a modern example on the left of a sedimentary environment, a dried up, what's called a playa lake bed. And this is a lake bed that has dried up after a rainstorm, and it is uh, it's probably like the Bonneville Salt Flats, and it's after the rainstorm in the mud, the sun bakes it and cracks it. And the same thing has happened over here on the fossilized side on the right over here. But this is the Culpeper Stone Quarry in Virginia. Okay, so you can see that once upon a time in Virginia, there was a lake that would flood and get muddy, and then the sun would bake it. But if a dinosaur were to walk on it before the mud had dried, it becomes a dinosaur track, and that's what happened here. This right near these mud cracks are dinosaur tracks like the one at the bottom of the page, and this is how that dinosaur track was preserved that I showed you earlier. Dinosaurs were walking around a lake like this after a rain, and they put their footsteps in the mud, and then the mud got baked by the sun, and the mud cracks happened after the prints were already in it, and then it gets buried by another flood with sediment, and the whole process repeats itself, like stacking layers of sediment on top of layers, until one day in the about 1980s or 90s, a quarry was digging in there and blasting and digging up the rock to make gravel out of it, and they discovered the dinosaur tracks in an old lake that used to be in Virginia. All right, and if you want to see what it looks like inside the quarry, here's a picture. So you can see the quarry has been blasted out, and it's this surface down here that everybody is sitting on, and that's why all these people are here. They're here to see those dinosaur tracks. All right. And another good example of modern ripples, you've probably seen these at the beach. On the left side, this is what you might see at the ocean. And on the right side is what you might see in West Virginia or in the mountains of Virginia, where the rocks have been tilted vertically because of plate tectonics. These are fossil sand dunes. So if they're vertical, you know that they were once horizontal because of original horizontality, and it took a collision with other continent, Africa, to tilt these vertically. Crazy stuff. And White Cliffs of Dover. In case you didn't know it, there really is chalk in nature, and the chalk is actually little diatoms, radiolarians. They're microscopic organisms that have tiny skeletons that make up the chalk. And here you have some dinosaur bones, a fish, and in this case palm fronds from Wyoming. And there's tropical type lake freshwater fish and these tropical plants. It looks a lot more, this is an environment that would be like the Amazon today, but today Wyoming is cold. It's a dry, cold place, and it's not tropical at all, but it shows you how much the climate has changed. And by the way, the volcanoes that produced this ash, that buried this, you can see them nearby. They're eroded now, but the volcanoes are still there. And the famous Archaeopteryx. This is the oldest known bird ancestor, and what's really cool about it is you can see that it has claws on its wings, and it has a bony tail instead of just feathers. And if you could see its head, you would see that there are teeth in here. It wasn't a great flyer. You know, it doesn't have a large breastbone where the muscles of the chest, like the pectoral muscles, could attach. So it was not known as a very good flyer. It was more like a glider. It would be something like a flying squirrel going from one tree to the next. But it was a lizard, or not kind of a reptile dinosaur. It's what dinosaurs really were, is they were birds. They were very closely related to birds, particularly the the two-legged, the bipedal. And once again, that was also another volcanic ash event that killed that bird in a lake, knocked it down into a lake. All right, and there's T-Rex, but I'm going to stop right there and pick up with another video segment.